Energy transfers from form to form. We use energy through the different energy sources. The process for using each of these sources is the process of watching the different forms of energy transfer as they bring energy in one form to a usable form in our homes, in our cell phones, in our cars. We can categorize our energy sources into renewable and non-renewable. Renewable sources can be replenished in a short period of time. These sources include hydropower, biomass, geothermal, wind, and solar. These sources are used to generate electricity, heat homes, and transport people. Let's take a look at hydropower. Hydropower is what it sounds like. It involves water. This is energy that comes from the force of moving water. We know that the water cycle exists here on Earth. Sun keeps moving water through that water cycle. The water's energy is stored as gravitational potential energy, like when it's stored higher up in a dam. About 2.6% of America's energy consumption is through hydropower. We use this mostly for electricity. Hydropower dams release stored water from gravitational energy to electrical energy. As we go through, we have a diagram here. The water starts in the reservoir at number 1. When it's open, the water travels through the penstock, going from gravitational energy to kinetic energy. It spins a copper coil and magnet in the generator, generating electricity. So we've gone from gravitational to kinetic to electrical energy. Our next renewable source is wind energy. This is air in motion. It's caused by the uneven heating of the Earth's surface by the sun. You heat up the air in one area, it has to move somewhere else. That creates wind. It's about 1.6% of America's energy consumption, and we use it mostly for electricity. Moving wind generates electricity by moving a wind turbine, just like the water turbine did. Here we have a wind turbine diagram. We have the blades, which are moving because of the kinetic energy of the wind, and that causes inside the nacelle, so inside the head of the wind turbine, a generator to spin. So we're using kinetic energy to turn directly into electrical energy. Solar energy is energy radiated from the sun to the earth in the form of light, so radiant energy. It's created through nuclear fusion of hydrogen and helium in the sun's core. All of our energy, or most of the energy we deal with on Earth, starts as this nuclear energy in the sun's core, and then it comes through radiant energy or light energy to Earth. Right now, this is about 0.3% of America's energy consumption. We use it mostly for electricity, but also for heating. Energy collected by photovoltaic cells can transfer radiant energy, so light energy, directly into electricity from one form to another. And then we can use solar power to heat water and heat air. Here's a little diagram of how fusion works in the sun. Hydrogen comes together, giving out energy, helium, and an extra neutron. We are not capable 100% of creating this form of nuclear energy here on Earth. Geothermal energy. This is heat from the Earth. Geo meaning earth, thermal meaning heat. Thermal energy generated in the Earth's core by radioactive decay and an immense amount of pressure. So we're superheating water and air underneath the Earth. This is creating about 0.2% of America's energy consumption. We use it mostly for electricity and heating. So for low temperatures, heating homes, growing crops, drying lumber. High temperatures, the steam, so when the water gets hot enough that it turns into steam, we can use that to spin an electricity or electrical generator. Thermal energy starts below the earth and either comes up to a power plant or, like we see in the residential geoexchange units, the heat comes up and it's used to heat the house. We can either generate electricity or harness that thermal energy as thermal energy. Biomass, another reusable or renewable form of energy. This is any organic matter that can be used as an energy source. Wood, crops, yard, and animal waste. It's the longest used energy source. People have been burning wood and other natural organic matter for years. Energy is stored as chemical energy. It starts as photosynthesis in the plant, which is a byproduct of the sun that it's receiving, and it's creating sugars inside the plant. This is right now about 4.7% of America's energy consumption. We use it for a lot. When we burn it, we can take this organic matter, burn it at a waste to energy plant, and make electricity. When we burn it, about 900 kilograms of garbage is the same as about 225 kilograms of coal. The difference is we have a lot more garbage and burnable organic matter than we do of coal. It's also a lot easier to get that garbage. We can use bacterial decay. So if we take that organic matter and we use certain strains of bacteria, it'll give off methane as the plant and animal matter decays. Landfills actually trap methane gas and then burn it later to generate electricity. Or sometimes we use this organic matter and we ferment it, kind of like you would ferment alcohol. Instead, we're making ethanol, which can then be used to power and transport vehicles. The renewable sources can be used again and again. Non-renewable energy sources cannot. These sources cannot be replenished in a short period of time. When I say a short period of time, it takes about 65 million years at minimum for these sources to bring back enough energy for us to use. Coal, petroleum, natural gas, propane, and uranium are examples of non-renewable energy sources. We use them for many things: to generate electricity, to heat our homes, to fuel our cars, and to manufacture products. When we talk about non-renewable sources, we end up looking at a lot of fossil fuels. Fossil fuels are formed from the remains of tiny sea plants and animals that died hundreds of millions of years ago. The dead plants and animals sank to the bottom of the sea, and a lot of sediment, sand buried on top of them. Years of pressure and years turned that into rock. The pressure and heat chemically changed the mixture, so it changed this this pile of animal and plant life into hydrocarbons. Those hydrocarbons come together underneath millions of pounds of pressure and millions of years to give us petroleum, natural gas, coal, and propane. It's like taking the energy that exists in biomass and letting it stew together for millions of years under a lot of pressure. You're essentially getting the cream off the top. One of the most common fossil fuels you'll see is petroleum. It's often called crude oil or just oil. It's a fossil fuel, and its energy is stored in chemical form below the Earth's surface in porous rocks. So rocks that have holes in them so that we can easily drain this out of or pump it out of. All of our non-renewable energy sources had very small percentages, but petroleum is about 35.2% of America's energy consumption. That's a big percent. We use it for transportation mostly and manufacturing as well. We refine it into gasoline, diesel, heating oil, jet fuel to power our vehicles, but then we can also use petroleum, the same basic material that we can turn into gasoline, we use to make plastic, aspirin. You'd be hard pressed to look around your room or feel in your pockets and find something that is not made with petroleum. In fact, if you look at 1 barrel of crude oil or petroleum, only about 43.2% of it is turned into gasoline. The rest has other uses. We could turn it into other fuels, and then we can also use it in industry. Natural gas, another fossil fuel. Natural gas is colorless, odorless gas mixture. It's the main ingredient in methane. It's a fossil fuel, so it's formed the same way with millions of years and millions of pounds of pressure, and its energy is stored in chemical form below the Earth's surface in porous rocks, just like petroleum. About 26.6% of America's energy consumption comes from natural gas. We use it to heat our homes, to electrify our homes, and to manufacture things. Anytime you turn on a gas burner in your home, or if you have a gas-powered heater in your home, you're using natural gas. Nicor, for example, is a natural gas provider. It's used in the creation of fertilizer, glue, paint, laundry detergent, and many other items. So we use it for fuel, for energy, but also for manufacturing. Coal is a fossil fuel formed from the remains of plants and animals that lived millions of years ago. It's a fossil fuel, so all those hydrocarbons are pushed together for millions of years under millions of pounds of pressure. Stored as chemical energy, and we use about 18.5% of it for America's total energy consumption. That percentage is even higher when we look at how much we use it for electricity. We rely on coal for electricity more than other forms or other sources of energy. Most of it is used for electricity, but we also use it to heat and smelt metals, melt them together to make other metals. The process for using coal is similar to the process to use most of our fossil fuels that we burn. One, the sun creates nuclear energy using fusion. That energy transfers to the earth using radiant light. Two, three, that radiant energy transforms into chemical energy in a plant using photosynthesis. And then four, millions of years of time and pressure turn it into fossil fuels. That fossil fuel is then burned to boil water. That water is now full of kinetic energy and it starts moving a turbine. That turbine generates electrical energy, and that electrical energy transfers all the way to our homes. Propane is another common fossil fuel. Propane is a portable fossil fuel. It's energy-rich gas that's included in raw petroleum and natural gas. They're usually found together because they're all fossil fuels and formed in the same way. We pressurize it from a gas into a liquid so it can be transported easily. This is why it's so common for barbecue grills or for people who live in more rural areas and are no longer on NICOR's gas lines and need transportable fuel. It's only about 1.7% of America's energy consumption because we have a lot more infrastructure that can deliver natural gas and other forms of energy to people's houses now a lot easier. We use it mostly for heating, sometimes for manufacturing. Some people will use it to heat their homes if they are not on a natural gas line, but we do see it a lot for industry. We can fuel torches, provide portable warmth, heating asphalt. A lot of forklifts are powered off smaller canisters of propane. In the sun, we have nuclear fusion. Here on Earth, we use uranium for nuclear fission. U-235 atoms are split apart, releasing energy. Energy stored as nuclear energy. So uranium is used for fission. We split it apart. In the sun, we have fusion. We take those atoms and crush them together. This is about 8.5% of America's energy comes from nuclear power plants, and Illinois is one of the highest providers of nuclear energy. We use it mostly for electricity. It heats water, turns it into steam to move a turbine and generate electricity. So we see how that energy, that uranium-235, when it splits apart, it gives off energy.